Okay, let's get in how to solve this particular word problem. And this has to do with motion, and obviously it's going to involve two cars. So this is a classic algebra type of word problem. And in algebra, oftentimes the word problems you encounter are what I like to call classical, typical type of algebra word problems. Now, of course, the details of the problem will be different and the numbers might be different, but the general strategy and approach will be very much the same for a lot of these kind of typical word problems. So I've been posting videos on these various word problems. Of course, you can find those in my pre-algebra and algebra playlist, but we're going to get into this particular problem here in just one moment. But first, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher, and over several years, I've constructed what I like to believe is one of the best online math help programs there is. Of course, I'll let you be the judge of that. You can find a link to my math help program in the description of this video. But basically, I have 100 plus different math courses. I have all the main courses, pre-algebra, algebra 1, algebra 2, geometry. Going to be launching pre-calculus here very soon. I have college algebra. I have a lot of specialty courses in the area of test preparation. So if you're preparing for an exam like the GED, SAT, ACT, Accuplacer, CLEP exam, ALEX, teacher certification, ASVAB, there's a lot of different type of exams that people have to take are very, very important in their life. And if you don't do well, you don't get to the next step in your goals. So a lot of these particular exams have a lot of mathematics on it, so I can help you out for sure. Just go to my site, check out my full course catalog. I also work with independent learners like homeschoolers. I have a great homeschool learning program, so if that's your situation, I can definitely help you out. Then obviously I help those of you who are just struggling in math and you're like, oh man, math is tough. I'm glad you found me because I think I could definitely help you out. If you like my teaching style, you're really gonna like my math help program. But one thing you need to be doing to help yourself in mathematics, and I'm assuming that you are interested in learning mathematics, if that's why you're at this video. But the one main thing, most important thing you could be doing is taking great math notes. Over decades of teaching math, one thing is apparent to me, those students who take great math notes almost always have great math grades, and those students who just are not into note taking, they say, I got a photographic memory, it's no big deal. Notes are, yeah, I'll take some notes sometimes, and that's not going to work. Okay. So if you've been getting kind of been able to get away with it, I'm going to tell you right now, as you continue on learning mathematics, there's just no way you're going to be able to do well without taking great math notes. So it's an area you definitely want to improve so you can really focus and engage and learn all the material. So if you need to improve in your notes, and most of you do, okay, just start making a more concerted effort, immediately. Let's just say that much. But yeah, I mean, maybe half of the year has gone by and you still need something to study from. So I offer detailed, comprehensive math notes to include pre-algebra, algebra 1, geometry, algebra 2, and trigonometry. You can find links to those notes in the description of this video as well. All right, so let's read this problem. Then I'm going to talk about the general approach to word problems. And I mean general because not every word problem is going to be a little bit different, but we do have some general kind of problem solving techniques that we need to kind of apply. So let's go ahead and read the problem. So it says two cars heading for Tampa, Florida. That's a great city. So two cars heading for Tampa, Florida along the same route left a gas station at the same time. Okay, their average speeds are differed by 12 kilometers per hour. Okay, so the faster car reached Tampa after 6 hours of travel time. The slower car took an hour longer. So we want to find the average speed of each car. Now, a lot of information here, okay? And a couple of things that kind of stand out to most of you. So first of all, we're using kilometers per hour, not miles per hour. But that's okay. It's a metric system, kind of, cars in Europe and whatnot will use kilometers per hour. Here in the United States, we use miles per hour, but it's nevertheless just a way to measure speed. Okay. Now, we've got a couple different things going on, and there's no way you're going to be able to figure out this problem by reading through it one time. Okay. So I'm going to talk to you a little bit more about the problem-solving kind of approach for word problems. But let's just kind of identify something here. We're talking about average speed, okay? So average speed, the reason why this problem is talking about find the average speed of each car is because if you think about a vehicle, actually, let's see here, I got a little diagram right here of these vehicles. If we left a gas station, right? So here's a little gas station, and we're getting to Tampa. Cars just don't you don't put your foot on the accelerator and stay at like 70 miles per hour at one entire time. That's crazy, right? It's not like just 70 miles an hour the entire way. So what's actually happening? Well, in real life, you're accelerating and your speed's kind of fluctuating and you're decelerating, etc. So this kind of instantaneous speed of what's going on at any particular time, that involves a more exciting mathematics called calculus. So that's really cool stuff. So that's why you want to keep learning, is because in real life, real life problems, okay, we want more precise answers. We just don't want the average speed. We would want something like more precise speed. But this is what we're kind of trying to figure out, is like if these cars are going one speed this entire time, what was that speed? So that's why that average speed is in there, and hopefully that makes sense. Okay, so let's talk about the general problem solving process here, okay? Let me kind of erase this. Okay, now what do you want to be doing? Well, the first thing you want to do is read the problem. Now, a lot of you are like, please tell me I didn't waste my time watching this YouTube video for you to tell me that you have to read the problem in order to solve it. Yes, that's what I'm telling you. But you need to read the problem like at least 5 times, okay? So you read it once, get a flavor, sense of the problem, and then you just have to keep rereading it, okay? Looking for the details. Like, you got to be very, very specific on the information that's in the problem. So don't try to read the problem once or even twice. You're going to have to read it, get a sense of it, and just reread, and pull information out of it. So that's the first thing. Now, the second thing you need to do is kind of come up with some sort of picture or figure, some sort of model, all right? And it could be a little sketch, anything that helps you kind of figure out the variables, or basically to look at the problem in a more kind of graphical way. Okay, this is very, very helpful. And in this particular problem, I'll show you mine here in a second. Now, the third thing you're going to want to do in word problems is basically assign a variable. Okay, a variable or variables. It all depends on what type of problem that we're dealing with. In this case, it'll be a variable. So we're going to say, okay, we're going to let x equal to something. Okay, so we're going to do that. Now, if we're going to assign a variable, then what are we going to do with these variables? Well, what you're going to do is you're going to look for some sort of, I'll put it down right here, like a relationship in the problem where you can create an equation. Okay, effectively, we want to build an equation. That's what we want to do. So in the problem, we can pull out information that said, okay, this is equal to this, and then we can write an equation. All right, then once we have an algebraic equation, what are we going to do next? We're going to solve for the variable. Okay, for this case, let's say it's x. We're going to solve for x. And then the last thing we're going to do is we're going to make sure we answer the right question, the right questions, okay? Now, just because you solve for a particular variable doesn't necessarily mean you're answering the question of the problem. You got to really, go back and reread and make sure that, in fact, what your variable is assigned to, you have to use that information in order to make sure you're answering the problem. Because I've seen students go through all this process, beautiful. They'll solve for X, they'll give me their answer, and then I have to like take points off, and then they look like this, and they're like, what are you talking about? I solved the right answer. Like, yes, you solved for X, but you didn't answer the question. Okay, oftentimes when you solve the equation, that's not answering the question. So you're going to have to think about what this means. And when you set up the problem, you're like, okay, in advance when you solve for X, you're going to have to take an additional step to answer the right question. Okay, all right, so that's the general problem solving format for algebra word problems. And now let's get into this one. All right, so I've already read it once, but let's just kind of think about this again. So we got 2 cars. they're heading to Tampa. It could be anywhere. They're on the same route, and they left the same place. They left the gas station at the same time. Okay, so they left one destination at the same time, and their speeds are different. Okay, I'm just kind of doing a quick overview, right? We've got a faster car and we got a slower car, right? And then we want to find the average speed of each car. So we can kind of just think about this. I'm going to pull up more information like this. So we have the gas station. We left here. Here's the gas station right here. Okay, the gas up, and they go to Tampa. All right. So we have a slow car and we have a fast car. So here, obviously, the slow car would be behind the fast car, and they traveled the same distance from the gas station to Tampa. They did cover the same amount of distance. All right. Now you can see here, um, one of the cars took 6 hours. The other one took another hour longer, okay, to get there. But we'll get into all that in a second. Let's just get a general idea, kind of graphically what's going on. So here we got the gas station. Here's Tampa. We got a slow car. We got a fast car. So why don't we assign a variable? Let's just say x is equal to the rate of the slow car. Okay, so that's the speed or the rate. And so that will be in kilometers per hour. Okay, so let x equals the rate or the speed of the slow car. And we know that, kind of going back and rereading, that their average speeds differed by 12 kilometers per hour. So if there was a 12 kilometers per hour difference, well, the faster car must be going 12 kilometers, faster than X. Okay, so whatever this slow car's speed is, 12 more is going to be the speed of the faster car. So we'll let X plus 12 equal the rate of the faster car. Of course, that'll be in kilometers per hour units, and our distance, they travel the same units. That'll be in kilometers. Okay, so if you're not familiar with the metric system, kilometers are like, they're shorter than miles, and then kilometers per hour is kind of like miles per hour. All right, but you don't really need to know all of that. You just need to know that kilometers is a unit of measure for distance, and kilometers per hour is a unit of measure for speed or rate. All right, so this is what I'm talking about, to create kind of a figure or model by pulling out information in the problem. Now we're going to have to go back to the problem again, just to kind of make sure we're, answering the right question. But from here, we can get to a very, very important chart. Now, let me go back up here real quick. Okay. Now, one thing I need to add in here, all right, I'm gonna erase this real quick. Very, very important. Let me erase it. I've talked about this in other problems, but here in this particular problem, I want to stress one thing. You may also need to know formulas, okay? Formulas, basic formulas in motion, physics, and things like that. This might come up, but one of the most common for sure is the following. Rate times time is equal to distance. This is a super important formula. You need to know this in order to solve this problem. Now, rate is like our speed, okay? And t is obviously our time, and then d is our distance. And you got to be very careful with units of measure. So, for example, if our speed is miles per hour, okay, and our time is hours, then our distance will be in miles, okay? If our speed is in kilometers per hour and our time is in hours, then our distance will be in kilometers. So I've done other videos on motion problems and units of measure, but you need to be familiar with formulas and units of measure. Of course, there's a lot of other things that kind of go into solving algebra word problems, but formulas, this one here, you definitely want to commit to memory. It comes up quite frequently. Okay, rate times time is equal to distance, and you got to make sure you have the right units of measure. Okay, let's get back to our problem. So now what you can do is build yourself a nice chart, a nice table. This comes in handy, all right? So we got our cars. Let's just put this here, our cars. So what kind of cars we have? We have a fast car, and we have a slow car. So we're going to figure out what we're going to categorize the rate, the time, and the distance for each of these cars. Okay, so let's start with the slow car first down here, okay? So remember, we said the slow car, we're going to let x is equal to the rate of the slow car. All right. And we know it took 7 hours. Okay. Now, how do we know it took 7 hours? Well, the fast car went to Tampa in 6 hours. The slow car took an hour longer. So we have to go back and pull information again, read and reread and reread, to figure this out. So the slow car was going X kilometers per hour. It took 7 hours. That's what its time. Remember, it's in hours. Okay. So its distance is its rate times time. Okay. Rate times time is equal to distance. So the distance of the slow car is 7x. That's how we would express that in algebra. Now, let's talk about the fast car. We said it was going x plus 12, right? The speeds differed by 12 kilometers per hour. So the speed of the fast car is x plus 12, and we know it also took 6 hours, right? The fast car reached Tampa in 6 hours, okay? So we have x plus 12, all right? That's its rate, and 6 is its time, all right? So when we multiply those together, one thing that you also have to be very careful with, we do 6 times x plus 12, that's the distance. When you have a sum or difference like this, if you're adding anything to a variable or subtracting, always just put these in parentheses. All right. Oftentimes students will not do that and they'll get themselves in trouble. But what we're going to have is 6 times x plus 12. That's the distance of the fast car. Now let's just think about it. How much distance did each car travel? Well, both the fast car and the slow car went the same distance. They went the same distance. They went from the gas station to Tampa. Okay. So at this stage of the game, we want to set up an equation. Well, one thing I could do is say, well, this distance here is got to be the same as this distance because they traveled the same distance. Okay. They went from the gas station to Tampa, and that's exactly what I'm going to do. All right. So the distance of the fast car is the same thing as the distance of the slow car. So from our table, we have the distance of the fast car is this. Okay, again, go back to our table. This is the distance of the fast car, 6 times x plus 12, and then 7x is the distance of the slow car. So now I can create an equation. Now, if you've done this part all correct, okay, and let's say this question was worth out of 10, and then you made some mistakes at this point forward, most teachers would probably give you like a 6 out of 10 points, okay? If you're showing all your work, you would get a lot of partial credit for just showing the structure of this problem, all right? This is why it's so important to be neat and organized and structured in your problem solving, okay? As a teacher, I've graded thousands and thousands. I mean, I don't even know. It's a ridiculous amount of years and years and years of grading things. And, you're not going to just, it's not pass, it's not, some questions are true, false, or whatnot, but most of the time there's partial credit. If you're showing me you understand a lot, I'm going to give you some partial credit. If you're showing me you're just skipping work and it's confusing, then you're not going to earn any credit. All right, this is why it's very important to follow this kind of procedure, if you will. All right, so at this point, this is where you need your kind of algebra solving skills. So here I got to solve this equation. So it's going to be 6 times x. That's this is the distributive property, 6x. Then 6 times 12 is 72. And now I can simply subtract x from both sides of the equation. And I get 1x, or x is equal to 72. Okay, but what does that mean? Well, let's remember x was the rate of the slow car, right? So that's why I'm talking about here. You're not just done. Oh, I solved the problem. No, no, no. You want the average speed of both cars. So we got one here. So the slow car average speed is 72. Now, 72 what? Make sure you put in the units of measure, kilometers per hour. And again, this average speed means the following. Let's think about it. Here's the gas station, and here's Tampa. And the car didn't just go 72 kilometers per hour the entire time, right? It's in real life, it's accelerated and it was adjusting its speed and then it went down. So that's why we use this word average speed. This is like a very simplified model of what's occurring in reality, right? But to have that more precise, um, actual acceleration and rates of change and stuff that requires calculus. But don't worry about it. That's why we need to put in this average speed. All right, now we want to get the speed of the faster car, okay, the other car, so that's going to be x plus 12. Remember, the speeds differed by 12. So we know the slow car was at 72 kilometers per hour, so we're going to add 12 to that, so that gives us 84 kilometers per hour. And now you are done. And if you got this problem right, I would be like so impressed. I'd be like, boy, you are awesome. Here's A plus. Here's 1,000%. A few stars. Matter of fact, I might be so impressed. Be like, just take the textbook, go home, check in with me next year. Just teach yourself. You're outstanding. Now, obviously, I'm kind of being funny about this, but this is impressive, right? If teachers love to see this kind of work because you're showing, how to organize a problem, read a problem. That's what mathematics is. Mathematics is problem solving, and you're applying multiple different skills to that problem. So, you know, you know, uh, can you watch this video and then be like, okay, I'm good. I don't need to put this in my notes or practice this. Of course not. This is, practice, 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 and making mistakes and figuring things out and getting better at this. It's a skill, okay, and somewhat of an art form as well. Two, three, four different students could lay out their problem a little bit different, but still be, demonstrate excellent skills and an excellent approach. So your problem. Um, or your solution to this particular problem could look a little bit different, but it could still be outstanding. As long as you're telling the story, it's organized, it's structured, then you're going to be good to go. So that's why you got to practice this stuff, right? And a lot of people are terrified of algebra word problems. They're like, no, no, please, anything but an algebra word problem. Listen, they're not that bad, but like anything else, you're going to have to face it and build up to it, right? And that's why note taking and things like that is so important. Okay, so if you feel like this video helped you out, well, then please consider helping me out by smashing that like button. And if you're new to my YouTube channel, please consider subscribing. I've been on YouTube for a long time. I have hundreds and hundreds and hundreds of videos on my channel, organized from basic to advanced math, all there for you. And I'm posting new stuff all the time. But my best resources will be found by following the links in the description of this video. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.